Vocabulary words. The first two vocabulary words deal with types of rules that we're going to be working with. So the difference in the two rules is that a postulate, also known as an axiom, is accepted without proof, and a theorem has to be proved. And we'll deal more with theorems in the next chapter. So right now we're going to work with postulates. They're generally common sense rules. Also, we have the definition of congruent segments. We're going to get the definition of other congruent items as well. The key to congruent segments is that they have the same length. So we need to make sure we understand how to represent this information. So when we talk about congruent, we're talking about the segments themselves. So segments are congruent. So you would write the name of the first segment. We would use the symbol for congruent, which is the equals, and it has this little curve over the top. And then we would write the name of the second segment. And this means that the lengths are equal. When you're talking about the lengths, we leave the bar off the name, so we just use the two endpoints without any symbol over the top. This represents the length, and it will equal the length of the other segment. So the segments themselves are congruent, and their lengths are equal. So if you have equal lengths, they're congruent, and if you have congruent, they have equal lengths. Our first postulate is the ruler postulate, and most of you probably feel comfortable using a ruler to measure a segment, but most of you always start out with the ruler at 0. This postulate basically tells you what you can do if it's not lined up at 0. So we can match each of our endpoints with a number. These are now the coordinates. Use a different number there. These are now the coordinates of our endpoints, and our distance between them is going to be written just like our information on the other page with the two endpoints, and we do the absolute value of the difference between the coordinates. So the length from A to B is the absolute value of our coordinate of A minus the coordinate of B. So this is the absolute value of -5 to get a length of 5. Keep in mind that if you want to avoid absolute values, just make sure you always take the larger coordinate and subtract the smaller one. 7 minus 2 is 5, and the absolute value of 5 is 5. And then we have our segment addition postulate. So we have a segment, excuse me, that has been separated into pieces. And one of the requirements of this postulate is that we have to have a point somewhere between two other points. So we either start out knowing that it is between and get the calculation, or we have the calculation and we get to say that our point is between. And we get an addition. So this is addition. So we're going to be doing addition to equal. So what we have is we have the segment length of AB. AB is our first part. And then we have our second section, which is BC. So this is our second part. And then we have AC, which is the whole thing. And this is the key to the segment addition postulate. This is actually the key to all of our addition postulates. So we add the parts in order to equal the whole thing. So we add the length of each of the individual pieces to get the length of the whole thing. So if we know that we have some between information, we can add the parts to get the whole. And if our addition works out so that endpoint A to B plus B to C equals AC, that means our B has to be between the A and C on our diagram. So we're going to do some examples with this, and then we'll get the rest of the notes. So in our first problem, we are asked to draw a sketch of 3 collinear points and label them. I'm going to draw this so that A is between B and T. So I'm going to draw this so that I have my point A between my point B and my point T. Now that we know where things are located, we're going to write the segment addition postulate for these points. So we start out with our first piece, which is BA. We're going to add our second piece, which is AT, and this will equal the whole thing, which is BT. So the length of the first piece plus the length of the second piece equals the length of the whole thing. In our next set of examples, we're going to calculate lengths of items. So the first thing that we have is we are told that BC is 5. So our segment BC is 5. Next, we are told that AB and BC are equal. On a diagram, we indicate this with a common slash mark. Everything that has the same slash mark has the same measure. So since AB and BC are equal, that means AB is 5. And then we're asked to find the length of AC, which is the whole thing. So we use that segment addition. The first part plus the second part equals the whole thing. So AC is 10. The segment addition is not limited to a segment in 2 pieces. We can actually take a segment and divide it into as many pieces as we want. So that's our next example. We're told that HK is 9. So this whole thing is 9. We are also told that HI is equal to JK. So the length of HI and the length of JK are the same. So we're going to put that same little slash mark, and I'm going to call both of them X. And we are also told that IJ is 1. So this section from I to J is 1. So what I'm going to do is I'm actually going to use this segment addition postulate in order to calculate the length of those missing pieces. So the first piece plus the second piece plus the third piece equals the whole thing. So x plus 1 plus x equals 9. So this is 2x plus 1 equals 9. Subtract the 1. So 2x is 8. Divide by 2. So x is equal to 4. So now I know that each of these x values is 4, and I can answer all of the questions. So HI we just calculated as 4. JK we just calculated as 4. The next one wants to know H j. So we're going to add the pieces of 4 plus 1 to get 5. And the last one wants to know ik, so we're going to add the pieces of 1 plus 4 to get 5. Our next problem is going to require our algebra skills. So they start out by telling us that point J is between H and K. So if we draw this out, we have our point J between the H and K. So we are now going to use the segment addition postulate. So this means we're going to take our first part, which is HJ, so 3x plus 8. We are going to add it to our second part, which is JK. So this is our 2x minus 5, and we set it equal to the whole thing, which is KH. And remember, whether you're going from K to H or H to K, this is the same segment. So this is our whole thing of 23. So we add the parts in order to set it equal to the whole thing. So we calculate, combine our like terms. So 3x plus 2x is 5x. 8 minus 5 is positive 3 equals 23. We're going to subtract the 3. 5x equals 20. We're going to divide by the 5, and x equals 4. So we've solved for x, but notice that there is another set of instructions here. We are also asked to find the length of each of our segments. So don't forget to go back and finish this part. So we have our 3 segments, hj, which is 3 times the value of x plus 8. So this is 12 plus 8 to get 20. We have jk, which is 2 times our value of x minus 5. So this is 8 minus 5 to get 3. And then we have our whole thing of kh, which is 23. And if you do a quick check of 20 plus 3, you get 23 when you add them together. So make sure that the sum of your parts is equal to the whole thing. So we have one more thing in this section, and it's a formula. So this is the distance formula. So we have the coordinates of 2 points. Each coordinate has 2 values. We have an x coordinate, which is going to be used in our formula, and we have a y coordinate, which is going to be used in our formula. So each ordered pair has an x and each ordered pair has a y, and you have to pay close attention to where that information is in the formula. So notice our formula has this symbol here. This is our square root symbol. So we're going to be doing square roots. Order of operations. You're going to first substitute in x1, y1, x2, and y2. The next thing you're going to do is the subtraction that is in the parentheses. After we do the subtraction, you're going to do the exponent. So we have that square. Make sure you use parentheses around these, especially if you have negative numbers. After our exponents, we're going to do our addition that is between the two sets of parentheses. And last, we're going to do the square root. So substitute in your four numbers, your x1 and y1 from your first ordered pair, your x2 and y2 are from your second ordered pair. So we're going to fill in, and it actually doesn't matter which ordered pair you call first or second. So it's the x's in the first parenthesis, so it's the square root of x minus x, close the parenthesis squared. Notice this is a plus, and then you're going to do y minus y in the second parentheses and square. So be careful. You may also need to ask questions about how to do this in your calculator. So here is our examples. So each of the x's goes in the first parentheses, and our y's complete the second parenthesis. So in the ordered pair, our x's are the first numbers, and our y's are the second numbers. So when we go to fill in our formulas, we need to make sure we fill in with the correct information. So for this first question, we're going to find the length of a, b. So we have our square root. So if I have x1, y1, and then x2, y2, I'm going to do parenthesis 2 minus 3, close the parenthesis squared, plus parenthesis 0 minus 2, close the parenthesis squared. If we go through order of operations, you would do the two parentheses. 2 minus 3 is negative 1, and 0 minus 2 is negative 2. We would then do the exponents. 1 squared is 1 times 1, and negative 2 squared is negative 2 times 2. And then we would do the addition. And you would then either leave this in simplest radical form, or you would use the calculator and do the square root of 5. So this is approximately 2.24. Now, you can do all of this in the calculator at once. So you can do the calculator, and you can do parenthesis 2 minus 3, close the parenthesis squared, plus parenthesis 0 minus 2, close the parenthesis squared, and you'll see that it'll give you the exact same answer. So you can either do step by step, or you can type in the entire problem in the calculator. So when we look at the next one, once again, it doesn't matter which ordered pair is my x1 and y1, and which ordered pair is x2 and y2. We actually get the exact same answer at the end. So when we look at this one, we're going to find the length of EF. When we go through and fill in our formula, so we have that really big square root, parenthesis x2 minus x1, close the parenthesis squared, plus parenthesis y2 minus y1, close the parenthesis squared. So you will notice that there is a double negative here. Just because you have a negative number in your coordinate does not take the place of the minus within the formula. So So we have the minus from the formula and our -4. So we can go to the calculator. So we have our square root of -1 minus 2, close the parenthesis, up, minus 2, close the parenthesis, squared, plus parenthesis 0 minus -4, close the parenthesis, squared, and we get that the answer to this is 5. In the next question, we're told to use the distance formula to decide if segment AB is congruent to segment BC. So we need to find the length of AB and BC to see if they're equal. So we're going to work with A, which is 1, 0, and B at 4, 2. And then we're going to work with B, which is 4, 2, and C, which is at 7, 4. Keep in mind that the first numbers are the x's, and the second numbers are the y's for our distance formula. So for AB, our square root of parenthesis x2 minus x1 squared plus parenthesis y2 minus y1 squared. So this set of parentheses has the y's, and this set of parentheses has the x's. For BC, we're going to do the distance formula. It's going to be x2 minus x1 squared plus y2 minus y1 squared. So our x's together in the first parenthesis and our y's together in the second parenthesis. Now we need to go to the calculator. So for AB, we're going to do the square root of 4 minus 1, close the parenthesis, squared, plus our parenthesis 2 minus 0, close the parenthesis, squared, and this one is approximately 3.61 BC. We're going to go through the same process. Let's see if I can move this over. So we have square root of parenthesis 7 minus 4, close the parenthesis, squared, plus parentheses 4 minus 2, close the parenthesis, squared. This is approximately 3.61. So if we look, our two answers are equal to each other. So the answer to this question is yes. So once again, make sure you use your calculator carefully as you go through these problems.